Okay, just going through some of the mini mock questions because I know they cause people stress and people weren't good at them and people didn't like them and people panicked and people didn't do well on it sometimes. But um, it's not a huge deal. I just know that it can sit with you if you don't know the answer. You don't know how to do it if it kind of you feel like it beat you. So I'm gonna do these so you can have a chance. I know some of the teachers are gonna go through some corrections. Um, Sometimes they don't go through all of them. Sometimes they start off doing corrections, but then end up just wanting to move on to the next thing. So they end up leaving it about halfway through. If you've seen some of them, by all means, you can just like obviously look for the one that you're looking for, if you're looking at all. Um, but yeah, okay. If you want me, I probably won't go too deeply into either any of them anyway, as well. So if you do want to see one or have me explain it, like text me when next time I'm talking to you and just ask about something specifically. Just to save time, I just thought I'd do this. So the first one is it's a very complicated looking function, very complicated looking graph, but it's the idea of and whoever gave me this exam wrote it in here. I assume it was when they were doing corrections in class, I imagine. Find the coordinates of the point where c crosses the y-axis. C is just the name of this function. It looks horrendous, as I said, but when it crosses the y-axis on the graph, on the x and the y-axis, basically on the y-axis, all the x's are going to be 0. So this point would be 0 and, I don't know, 8 or something. This point would be 0 and 4. This point would be 0 and 0. And some point down here might be like 0 and -2, right? They're all 0 on the x-axis, or on the y-axis, sorry, the x's are always 0, and then on the x-axis, the y's are always 0. So that would be like 4 comma 0. And then over here, it would be 9 comma 0. It's always going to be that. So if they ask you, for example, where it crosses the y-axis, or down here later on, they'll ask you where it crosses the x-axis, that's kind of code for them saying, instead of crossing the y-axis, you can read that as when x equals 0. So instead of saying find the coordinates at point where c crosses the x-axis, read it as find the coordinates at point where c has x equals 0. That's the same question, right? And all that means is basically you're going to take c, which was given by this equation up here. C was the name of the curve and it was given by the equation. Some of these are mock questions that are written in a way that are just kind of strange. I'm hoping none of them are ones that I'm unable to do. But basically, because I'll have to pause and pretend I know what I was doing the whole time. So basically what you would do is you would just say, well, when across the y-axis, x is 0, so that's all I'm going to do. All the x's I see I'm going to replace with a 0. Now, that is a bracket in the wrong spot. So it should be like this. Now, you can put all of this into your calculator in one go. From here, and you will just get down to the answer. I'm just going to kind of show you that basically this would be 2 times 0 minus 0 plus 2. Here, you have to do the squared first instead of multiplying by the 2. People keep trying to multiply by the 2 first. You can't do that, right? So don't do that. Anything to the power, now e to the power minus 0 is the same as e to the power of 0. Anything to the power of 0 is 1. So then you're just multiplying this whole bracket by 1, but this bracket is 0 minus 0 plus 2 times 1, which is 2 times 1, which is 2, right? So the answer when x is 0, which we know is on the y-axis, so it's going to be here. The x is going to be 0. We know that because that's what the thing was insinuating, and we know that when x is 0, the y value ends up being 2 for this. So that's that point up there. It's going to be 0 and 2. Now down here, it says show that the c crosses at x equals 2, right? So there's a slide. I did mention that they talk about crossing the x-axis. In the question stuff, it says and or hence or and then using your answer. Kind of like put a break in there if you know what I mean, and just do the first bit first without looking at the second half. Don't look at the second half just yet. I know I referred to it earlier and it might be confusing. Don't look at the second half yet. It just confuses the whole thing if you try to read the whole, because you'll read the question and try to do it all together when really it's two different elements to it. So show that c crosses the x-axis at x equals 2. Again, on the x-axis the y value should be 0. So that means if we sub in, now there is a way of doing it where technically we sub in 0 for y and solve and show that 2 works, but if they give it to you, what you're allowed to do is, as this person has written in, you're allowed to just sub it in. And basically the idea is if we sub x in for 2, we would hope to get the y to be the 0, because as we said, if it's on the x-axis, the y value has to be 0. So if it says show that it crosses the y-axis or the x-axis at x equals 2, it basically means show that when you sub in 2, you get the y to be 0, because y being 0 means it is on the x-axis. So that's what I'm going to do. Now again, you guys will be able to type all of this into your calculator in one go. And I would advise that, particularly because of the E. Yeah, but I'm just going to show you, because I have to do it out this way just to be sure. What you get is 8 here, you get minus 10 here, and you get plus 2 here. Now, e to the power minus 2 would be a weird decimal, but the thing is, the first bracket just ends up being 0, and anything multiplied by 0 is 0. So yeah, when x is 2, the y value is 0, and that means it must exist on the x-axis if the y value is 0. So therefore, yeah, show that the thing crosses and x equals 2. We've done that, that's fine. Because we've shown that when you sub it in, the y value is 2. I know I keep just repeating myself. I'm just kind of trying to stress that point because I don't think you guys know that. Now we can finally look at the second part of that question. It says, and find the x coordinate of the other point where the c crosses the x-axis. Now, this is the trickier one because they didn't tell us what it could be, like they did in the first half of the question where we just subbed in 2 and we said, oh, it's equal to 0. So what you could do is, hypothetically, just keep subbing in different numbers until you get 0 again a second time. I wouldn't advise it. Yeah, I wouldn't advise it at all. So what you could do is, yeah, keep subbing in numbers like the 2, keep guessing numbers until you do eventually get 0. However, what I'm going to do is I'm going to do the official way, that if I know it's crossing the x-axis, I know that the y value is 0. Again, I could have done that for the first half. I just chose not to because it's easier just to sub in the number they give you. So here, what I'm going to do is I'm going to rewrite out the original guy up here, but change the y to 0, because again, on the x-axis we know that's true. And then over here it would look like this. Now, because this way will give us all of the roots, one of our answers should be the x equals 2 that we've already proven is a root. But we're going to do some shenanigans here now. Now, you'll notice that we have two things being multiplied together, this guy and this guy, and we're getting 0 as an answer. And the only way that can occur is if one of these two is 0, because the only way you can multiply two things together and get 0 is if one of the two entities being multiplied is itself 0. So either the first bracket is 0 or the second bracket is 0. So what we can do is we can say 2x squared minus 5x plus 2 is equal to 0, or e to the power minus x is equal to 0. Thing is, though, this just does not work. That is just not true. Any number, any 0 or positive number to a power, like 0 to the power of x is obviously a bit nonsense, but like if I did 2 to the power of x, or 14 to the power of x, or if I did pi to the power of x, or I did e to the power of x like we saw here, none of those will ever give you a 0, because you're basically saying, how often would I have to multiply a number by itself to get... 0 would work. I'm thinking of negatives. Ignore the 0 bit. That was me being stupid. But that's for a different scenario. That's if this was a minus. That's another instance that comes up. Sorry, my bad. But basically, none of these will ever really give you 0 as an answer, because you can't multiply 2 by itself a certain amount of times until you get 0. That just doesn't make sense. You can't multiply 14 by itself, or pi, because that's really 3.14, and e is technically 2.718 or something. So no matter how many times you multiply them by themselves, you'll never break it down to 0. Even if it's a minus, or even if it's a 0 in the power, that just won't work. So what we actually do, and this upsets people, is we kind of just go, ignore that one. That one can't possibly be the 0. It has to be the first bracket. It has to be the 2x squared element had to have turned into the 0. If you want to be sure and play it safe, what you could do is use the top right of page 21, where you would change that to log base e of 0 is equal to minus x, and your calculator should tell you, if I'm correct, I'm tired so this could be fucked up, but it should tell you that that is an error, and you would go, oh, well then that one doesn't work because Graham said so. Basically, if you don't trust me, just gonna go with that. Here you'll notice it's a quadratic. You can just do the minus b, or you can use the brackets. It's up to you. I would suggest using the minus b, because I know the teachers tell you should be able to do it, and that's fair, I guess, but like it's easier for the teachers and myself to do that because we do maths so much more than you guys. But again, you do the quadratic, you can do the minus b and you get two answers. If you do it this way, you get these two, and you end up getting x is equal to a half and x is equal to 2. If you do it, I skipped a few steps there just because I'm assuming everybody would do the minus b, or if you are doing the brackets way, you're actually okay with the brackets to begin with. So you'll notice that one of the answers is 2. Like we kind of assumed or proved, sorry, that 2 would work. We've already shown that 2 does exist once on the x-axis. It is one of the points where c crosses the x-axis. We've just found out that the other one must be a half now. That's all, because it said prove that x equals 2 does exist as a root, and we did that. And then it says show that show what's the other one. Technically this question is weird because you could have just done the right hand side and you would have answered both of them, you know, like the right hand side of what I've done, right hand side of the line, you would have answered both of them, but you wouldn't have known that. They didn't want you to do that. The question was just worded weirdly. Normally they do this as maybe a part A and a part B, but that's what they wanted. I don't know how people feel about that. I'm not really paying too much attention to. I'm kind of just making sure I have the answers out. I'm not too sure how much in depth I need to be going with this. I feel like it's okay what I'm doing, and if you guys have an issue, as I said, just let me know. Yeah, now they asked for dy dx. I think I got all these things down, right, but they were all in a weird order. I think I put them together correctly, and I do remember you had to differentiate this. I hope it's in the right order. But it says find dy dx. We all know that means differentiate, get the derivative, use calculus, whatever. Find the rate of change, find the slope, find dy dx, find f dash x. They're all the same thing. So it means differentiate this, but you'll notice that there are two elements here being multiplied together that both have x's in them, so that means you're required to use the product rule. It's on page 21 or page 25 of your log tables. But basically what you would do is you would assign the first one as u, the second one as v. So we can say u is equal to 2x squared plus 5x minus 5x, sorry, plus 2. V is equal to e to the power minus x. And then for the product rule, we're going to need to be able to differentiate both of them. And if you differentiate, this top letter goes on top, or the first letter goes on top, the letter that you're actually differentiating goes on the bottom for you guys. So that'd be 4x minus 5. And dv dx. Now dv dx is kind of trickier to do. There's actually on page 25 of your log tables, in the column in the box on the left, it has e to the power of ax. Differentiated would turn into a e to the power of ax. And in my example, I think you'll notice that instead of a, we'd have a minus technically 1x. Down here, this is technically a minus 1. There's a 1 in there in a sneaky way. So this would turn into minus 1, but I'm not going to write the 1 if that's okay. You could technically write a 1 in here and a 1 in here. I'm just not going to do it. Just out of pure laziness. So down here, you could have used the chain rule to figure this out, but if it's on page 25, we might as well just use it. Then the product rule, just basically, if you remember, the product rule kind of needs you to mix and match them as far as I'm aware. I hope that's right now. I hope I'm not fucking that up. But basically, that would be 2x squared minus 5x plus 2 times minus e, times minus e to the power of minus x plus then the other way around. Oh yeah, I remember somebody correcting this. One of the teachers told people to do it a certain way, and I'm going to have a word about that now in a second. Basically, what some people did was they multiplied this bracket out, and they added the like terms as best they could. And the teacher gave them full marks, but then a few of them were kind of like, oh, you need to simplify this, or you need to put it in simplest terms. It does say give it in the simplest form, but I would argue... Well, I don't know. Maybe it's a very official term that I just don't know. But I would argue that it kind of just depends on your personal preference. I think simplest form just means, like, don't leave it like this. But I'll show you what I mean. Yeah, I'll just do it first, right? Well, yeah, I'll do it first. I'm trying to skip steps, but you guys mightn't have been able to see that, so I won't do that. So then you have this. And you have this, and this might be weird to people when I say like terms, because people might look at this and not be able to really spot like terms. But here there's an x squared and an e to the minus x. There are no other of those that exist, so that's fine. He's on his lonesome. Now there's an x and an e to the minus x, and here there's an x to the e. So these two go together and these two go together, because you notice that the two squiggly lines don't have x's on them, and the two straight ones do. So we can actually add them together because they're like terms, so we can do that. And we can put those together because they are also like terms, like that. If you're adding a's like this, you kind of just treat e to the minus x as like a y or a t. So if you had 5t and you had 4t, you'd make 9t. You know what I mean? It's the same kind of idea. You're just saying how many of them you have. Oh, I have 5 and I have 4 of them. Therefore, I have 9 of them. That's what I did there. Now, some people wrote this and they got full marks, but because it says simplest form, the teachers were a bit kind of. I think someone might have gotten 9 actually out of 10 for this, but the teachers were a bit kind of just making sure you're okay with it. One of the things you could have done is take out what's common at this point. Now, if you were, I don't know how adept at maths you'd have to be to spot it, but you could have spotted it up at this line and done this here. But if you take out what's common, you can take out an e to the power minus x out of all of them. And that's what I would have done to put it in the simplest form. But some people think that if you remember on page 21 of your 21 on the left hand side of your log tables, it says that if you have, I think they use a to the power minus p, that's the same as 1 over a to the plus p, right? So what people did was, or what some of the teachers said was, they said, oh, this e to the minus x kind of fits this kind of pattern, so we'll follow that pattern. And they said that means that, I'm going to just do this kind of scummily so I don't write out the whole thing. You change that to 1 over e to the power of plus x. And then if you change this to a fraction, that's like a big ass fraction over 1. And you do top by top, bottom by bottom, you'll eventually end up with, I've skipped a couple of lines there because I'm not too pushed about this. Like even if it is just you lose 1 mark, I'm not too pushed. But it ends up being that. And I think that's it in its simplest form. In some people's mind, I would have liked it with the e to the minus x just because I don't like fractions. But that's that. Each of their own. Yeah, I think that's it. Yup. I'm deathly afraid I'll make a mistake in one of these because I know you fuckers will let me know. And that's the problem. With Glee. Someone did think I made a mistake one time before actually, and he tried to let me know. He was wrong though, so best come prepared, I suppose. Make sure you're right. A circle. Now the circle question was kind of weird. Oh yeah, it was very weird because there was no actual diagrams, which is very unusual. Circle C has this equation, and you notice they didn't tell you the P and the Q. They told you the C was 43. Someone has written this in for me, so I don't even need to like prove to you that that's true. P and Q are constants. Again, that means if you find it, you'll be able to maintain it and use that for the rest of the question. You know, it's just like a number there that's not changing. They just hit it. The X is a number that could change. The Y is a number that could change, but the P and the Q cannot change. They're just stuck there. They just have been covered up. Now, given that the points blah and blah lie on the circle C, find the values of P and Q, and hence ignore that shit till we get there. So I'm putting a break in that, and we're going to come back to him later. So given that these points are on the circle, find the values in P and Q. Now this is something that weirdly would have been easier in ordinary level students to do because they know how to do this. This isn't really taught to honors students as much, but then the questions are starting to hit on ordinary stuff in the honors questions. So basically, if a point is on the circle, we should be able to sub it in for its x and the y. So this thing that this person has written in is correct. This one is actually incorrect. So we're going to ignore the P and the Q, right? Because that is not correct. I'm not trying to like shame anyone. But basically, what we're going to do is we're going to follow what they said here and say, oh, this is an x and a y. If it is lying on the edge of the circle, like if it is here, that means we should be able to sub it into the equation for it to make sense. We should be able to sub it in for the x and the y, so that's what we're going to do. So we're going to say minus 4 squared just into the equation, and everywhere I see that, I'm going to just fill in the relevant things. Squared plus 2. We still don't, sorry, no, not 2g, that was the wrong one. We still don't know P and Q though, so we're going to leave them as is for the time being. Oh god, Q, you guys know what I'm doing there. Plus 43 is equal to 0. And then when you multiply that out, you would just get, again, I might actually make a few mistakes here. I'm tired and I've fucked up a couple of things yesterday, so just be prepared. And then you would end up with minus 4p plus 7q. Now I'm just going to bring all the numbers over to the left hand side, and what is that going to be? 9175. Is that right? Doesn't sound right. 16 of, oh, it's because it's not right. 16 of 49 and plus 43, so that's going to be 65, 68, 108. I'm going to just probably get a calculator and check that now in a minute, but when I have something to say, I just don't want to have to pick it up and like type in all the thing, because you guys will just give out that, oh, it's too slow. Now, the thing is, there's an equation here, you'll notice, with two letters. If there's two letters, we cannot solve the equation. However, if there's two letters, guess how many equations would solve it? Two. Yeah, however many letters you have, that's the amount of equations you need to fix it. So, we're going to do the exact same with the second point they told us was on the line. So what we're going to do is we're just going to do the exact same shit, but sub in -2 and 5 instead. Kind of as a separate idea, but the same concept, right? So it's the same idea that if you sub it in, or if it's on the line, you should sub it in, and it should all work out to be 0. It should all work out to be what the thing actually says it should be. And that works for anything, not just a circle. It works for a line, it works for a parabola, it works for a circle, it works for an ellipse, it works for anything. If you find the equation of something and they tell you a point exists on it, you should be able to sub it in for the x and the y, and shit should go down perfect. 4 and 25 and 2p and 5q, 43, 0. Then you have 2p plus 5q. Again, I'm just going to move all of the things to either side if I can. I said it with confidence last time and then fucked it. 29 and 43 is 72. So it'll be -72. I forgot that should be a -108 up here, actually. Well, it should be a minus anyway. If it's 108, let me just, that would be 50, that would be 50, that would be, take 8. Yeah, I think -108. Yes, so you'll notice we have two equations now that have the same two letters. So what people would do is they'd label them as 1 and 2. And we're going to do simultaneous. Again, if you end up with two letters you're looking for, you're probably going to end up having to do a simultaneous at a certain point. It might be a hidden simultaneous that you wouldn't even notice, and you'll just do it anyway. But if you recall, to get simultaneous equations to work out when there's only these basic versions of them, from like, these are the ones you would have started to see in junior cert, you still need to know how to do them in leaving cert. But what you would do is you'd write one on top of the other, kind of like a sum in primary school. If you had 13 plus 17, you would have written it like this. You would have done the units as 10, carried the 1, and you said 1, 1, 1 is 3. So that's what we're going to do, but we want to do it in a way that when we add either the p's or the q's, they cancel out and get lost, and we're only left with one letter. The thing is, 7q and 5q, if we put them together, they're kind of weird. -4p and 2p, it's pretty cool, because if we multiply this whole line, well, this whole line by 2, the circle bit that I have here would be 4p, and -4p and 4p would cancel. So that's what we're going to do. We're going to double this whole line, and you have to do the whole line, including the 72. So then our first line would be -4p plus 7q, like this one hasn't changed, equals -108. And then you write down the second one, but I have doubled everything, so it will be like this. And again, I did not double it immediately. The whole point of this is to get the one of the things to cancel. And you notice the way I've organized it, and you can pick the two. You can pick it to be a 3 or a -4. Sometimes you have to multiply both lines by something. I have a video on simultaneous equations, go watch that. But when you do this, they cancel. This is 17q, this is -252. Oh, does that divide in? You divide both sides by 17, and you get q is equal to 182. No, that doesn't work. I fucked something. Okay, I guess I'll pause it and I'll see what I've done wrong. I'll see where I fucked up. Oh, okay, I'm annoyed. What I did was I forgot that this was a -2 that I was subbing in. I even wrote it here correctly. I just forgot to write it here, which would make this, instead of a +2p, this would make this a minus, which would make this a minus. So, basically, when I multiplied here by 2, now I could go back and edit this all out, but I honestly could not bother myself doing it. I could not be bothered. So, I'm just going to fix this on the fly, and hopefully you guys can figure it out. It's not too bad. But basically, because this was a minus already, this was a -2p. If I just doubled it, down here it would be a -4p, but then -4p and -4p wouldn't cancel. So, I multiplied by -2, because -2 by -2 would make it the +4p that I wanted in the first place. Hopefully you're all okay with that. Basically, I forgot there was a minus on there, so I got a 2p, and I knew I wanted a 4p, so I doubled it. Instead, I should have gotten a -2p, and I still want a 4p, so I just doubled it, but multiplied by a minus instead. So, instead, it's still going to be -4p, we'll cancel with a +4p, we just have to alter it slightly to make sure this does, in fact, turn into the 4p. Hopefully I haven't fucked it completely for every one of you. But basically, this is still going to be plus 4p. However, this bit would be wrong. This should be a minus. And this bit would be wrong. This needs to be a plus. And then what would happen is the same thing happens, right? We're still getting a minus 4p on the top line, which was still, he was still fair. We just need to make sure this turned into a plus 4p, which we did, but we'd have to have multiplied by minus 2 instead. Multiplying this whole line by minus 2 would make a plus 4p here, minus 10q here, and a plus 144 here. Now if you do the exact same thing that I did before, but if using the correct terms, the 4p's cancel, plus 7q and minus 10q is minus 3q. And then 144 minus 108 is going to be 36, I think. Divide both sides by minus 3. That's something actually a lot of people don't realize. They all just go, oh, I divide by 3. Divide both sides by minus 3. It's just easier. Do that in your calculator, you get minus 12 as one of your answers. We find out that q is minus 12. And then don't forget, for simultaneous equations, it works for all of them, really. But once you find one of them, the whole process is now just subbing in. So I'm going to take one of the original lines. I'm going to take line number 1 because it didn't fuck me up as much. And basically, I'm going to write minus 4p is still fine. And the plus 7q, the thing is, instead of q, I'm going to use minus 12 because that's what we found out q was equal to. And that's still equal to minus 108. I'm literally just taking line number 1 again and just subbing in the thing that we already know. Because then it would be this. And then this. I do apologize for getting it wrong. I hope you don't... I have visions of you all throwing your hands up in the air and being like, well, I knew this was stupid, I'm not doing it now. Yeah, God, yeah, I know I'm gonna hear some shit about that. Well, no one's gonna watch it, so it's fine, it'll be grand. Divides both sides by minus 4 though. While I was talking shite, I just got the answer. And it works out that p is just 6, right? So we know what p and q are. P is 6, q is minus 12. That could be wrong. I could have made another mistake with the fact that it's a whole number and they're kind of nice, the whole numbers. It kind of shows me that or it kind of makes me feel like I've done right. So I'm just going to go back up and write out their equation, but instead of p, I'm going to put in the 6. And instead of the q, I'm going to put in the 12. Well, minus 12, sorry. And then plus 43 equals 0. And now I can't forget, I did put a little marker here. I can't forget that that's there, right? Because that can often happen that when I tell people to not read the rest, they kind of do it and go, oh, answers, happy days, I'm done. It says, and hence determine the coordinates of the center of C and the size of its radius, and that is using just page 19 on your log tables, where as actually this person has written, don't forget this should be 2gx according to the formula, and this should be 2fy, and this should be the plus c, right? So what we can say is, we know, I'll just do it up on the top, but like you would just do it on the bottom, and you know, hopefully is don't think I'm that religious on it. You know I'm a bit of a slob. So you can say 2g is in place of the x, 2f is in place of the minus 12, c is in place of the 43, so that's fine. Divide both sides by 2 here, you get g is 3. Divide both sides by 2 here, you get f is minus 6, and they're both the final answer. So we have all 3 letters. And if again you go to page 19, on the log tables it tells you that the center is minus f and minus g. So therefore here the center would be minus 3 and minus 6, but I think we're all aware that that means that the center is minus 3 plus 6. You don't need to write the plus there, I just did it automatically. And then the radius, you have to follow the formula of g squared plus f squared minus c. Keep an eye out for that minus, that catches people a lot of the time. So that would be 3 squared plus minus 6 squared. Technically when you're subbing in for a number you should put it in brackets, right? And then minus 43, and that's going to be 9 and 36 is 45. Yeah, and then okay, it's going to be the square root of 2, I think. 9 and 36 is 45, minus 43 is 2, square root of 2 can't be done, square root of 2 is the radius. Okay, so we know that this is the center and this is the radius, and that's that done. Now, another bit, this is kind of like gaming the system here. You'll notice over here it says that, and this was part B, but this is on the next page, it says a straight line passes through the point A and is a tangent to the circle. If you recall, a tangent to a circle is a line that bounces off it in one spot. So, that's a bit thinner than I meant, but it means kind of like here. And they're saying it is a tangent to C at the point B. C being the name of the circle that they used in the first part. You notice it's over here. So I think you guys can see my cursor, so hopefully you'll be able to follow what I'm shiting on about. But basically this circle is called C. The tangent touches the circle at the point B, And the line, it says the tangent also passes through the point A, which is 4 or 5, somewhere on the line, like so. Now, because from the previous thing, we already found out that the center was going to be, I think it was, what was it, minus 3 and 6. Yes, and then that the radius was going to be root 2. We can use that information here because it says tangent to C, and that's what this person wrote in, needed C from part A. And I want to kind of show you how to game the system here. Let's say you had this question, right? You did not know how to do it, but you needed to do, oh, for fuck's sake, you needed to do this in order to get this. So if you didn't know how to do, let's say hypothetically you didn't know how to do, all right, okay, stop, get away. I don't know if that's just stuck. Okay. This here, you needed to get the answer for this to use it in part B. Let's say you didn't know how to do part A, but you did know how to do part B. In this question, you just go, oh, center is 1, 2, let's say, radius is 3. Just make any old shit up. Here, you get 0 out of 10. But let's say over here, instead of using these green numbers here, I'd use these red ones. I can still get full marks in this question. You still have to do it right, obviously. But if you do not know the starting information, just make any old shit up so that you can do the question and show them that you know all the formulas, you know the processes, you know like how to do algebra. You show them you're not stupid, you do actually know what you're doing. You just couldn't for the life you figure out the first one. Again, 0 out of 10 the first one, potentially full marks in the second one. But we're going to know how to do the questions, so it won't be a problem. But that is something that if you don't know the answers to part A, make them up, and then you can still get full marks. So over here, what was weird, as I said, they didn't have a diagram in these circle questions, which is very strange. But if they tell you the tangent, the important thing is generally always that the line that comes out to meet it is perpendicular to the tangent. So that those two lines are perpendicular. That's always important. There are 3 things you can do. I said it in the circles thing. You can either do perpendicular slope, perpendicular distance, which is the radius, or, as you would do in this scenario, you would join this to over here. And that's not going to make a straight line, of course. So, because it heats me. That's not much better. But you'll notice I've produced a right angle triangle. That's not going to be a right angle triangle at all. But that's the third kind of thing you can do, right? It's I would argue possibly the least common one. But I don't know that for a fact. There's your right angle triangle. What's cool about this is this part of the triangle here is the radius of the circle. So therefore, we actually already know the length of that side. It's square root of 2. I also forgot to highlight, they asked you, all right, they asked you for the distance from A to B, which is the length of the triangle on this side, because it is from A to B on the diagram. And they want you to show that that's 4 root 3. We know this is root 2. This side here, you can get by doing Pythagoras' theorem between minus 3, 6, and 4, 5. And that's going to be the square root of 50, I think. When you would just do the distance formula between this point and this point. The distance formula on page 18. I should have done it. I'm just lazy. Again, it's kind of one of those things that isn't really what I think trip people up, so I'm going to kind of gloss over it. You would call this x1, y1, let's say, and this x2, y2. You throw that in. And then you notice you have a right angle triangle where you have 2 sides and you're looking for the third, so you're going to use Pythagoras. Now, what way do you guys all like this again? You all like it this way, I think. I hate it. I abhor this way. Abhors are a good word, I think, for that. Don't forget the hypotenuse always has to be on its own. The hypotenuse is the one across on the right angle, so root 50 is the hypotenuse. He's the one that's going to be on his own. It doesn't really matter what you do for the other 2 sides here, so I'm just going to do this. So the other side that I know I put in as the root 2, and then the one that we're trying to prove is 4 root 3, I've left as b. This would be 2, b squared, and then this would be 50, because the square root and the squareds all cancel each other, don't forget. B squared is equal to 50 minus 2. B squared is equal to 48. And the opposite of squared again is... or the opposite of squared is the square root. I probably gave that away. I probably said the wrong thing. I don't care. I'm not going back. Square root of 48 is 4 root 3, I think. Yeah, now you guys can use your calculator. Your calculator will just tell you that. But I think that's right. And that is what they asked us. So that's happy days. So that's how you do that one. There was a common question. It was actually in one of the ones I did in one of the circle videos where I just did a rake of circle questions. What's next? What will I do next? It's probably this guy. But it's just, again, it was like a mock question, so there was no diagram on it. It was slightly different, and I just think it would just trip people up. But if you'd spotted it, it was easy to do. I don't think any of you would have been troubled with the actual maths of that. I don't think any of you are upset by the concepts, or don't know how to do the actual numbers. It's just you didn't spot it on the day. That's all. Because again, no diagram. Now, this one I'm going to do next, and I'm probably going to regret it, because I think this one caused an issue. But there were two questions like this, so it's going to be handy, I suppose. So they said, given that y is equal to 2 to the power of x. Now, this person has kind of put in notes themselves to kind of show what to do, right? But given that y is equal to 2 to the power of x, express this as an equation in terms of y. This is a common question, that this is atrocious, and they're saying everywhere you see 2 to the power of x, you can sub in a y instead. I know the pixelation isn't fantastic, but basically they're saying everywhere you see 2 to the power of x, you can change it to a y, because they are the same thing. That's what they've asserted there. They've said y is the same as 2 to the power of x. That's what the equals means. So everywhere we see 2 to the power of x here, we can sub in a y. The problem is, there isn't really a 2 to the power of x here. People would say, oh, that's 2 to the power of x, but this plus 1 is just kind of hanging on at the edge, so he's kind of a problem. So what we're going to have to do is use our indices rules to change that. So for example, 2 to the power of x plus 1, if you use the very first rule in your log tables on page 21, it says a to the power of p multiplied by a to the power, I think this is what letters they use, they would say this. Now, what I'm actually going to do is, and this, people don't like this, I'm actually going to go in reverse. You'll notice what we have here, it looks kind of like this, so I'm going to reverse it into your boy over here. Using that logic, now people are going to be upset that I'm writing this like back to front, if you follow me, and it's not a, but it's the exact same thing. This would be 2 to the power of x multiplied by 2 to the power of 1. Now I'm going to use brackets here. Here they didn't use brackets because the letters, it's kind of insinuated that you're multiplying anyway. With the numbers, it's maybe a bit less obvious, and the calculator has just been fishy recently for people when they were trying to do this. So I just thought I'd play it safe. 2 to the power of 1 is just 2 though, so really that is 2 to the power of x to be multiplied by 2, which is 2 times 2 to the power of x, which is, as we've seen, can be replaced as 2y, because they said everywhere you see 2 to the power of x, you can replace it with y. We've isolated 2 to the power of x, that's fine. So we know we can change him, we have him sorted. 4 to the power of x, we're going to sort out now. Now, I do it the right way. A couple of you picked the wrong way, so it might be that's the way you guys think. I say the wrong way. It's perfectly legitimate, I just don't like it. So what I would have done is, I'll show you what way I would have done it is, I would have taken the 4, and I would have changed it to 2 to the power of 2. Then there's a rule, I think it's like the third one down on your log tables, that says if you have a to the power of p to the power of q, that can turn into a to the power of pq, where it's implied that the pq are being multiplied together. So this might seem like shenanigans to you, but you can write that as 2 to the power of 2x. And then weirdly, using the same rule, because multiplication, like 3 times 4 is the same as 4 times 3. So weirdly, you can treat this as 2 to the power of x2, which is the same as 2x. People just do not like obviously nobody writes it like that. You don't even need to do this step when you're doing it. It's more so just to know that you can do that, because then if you do this step in reverse, you can write it as 2 to the power of x squared, which is y squared. So I know that the 4 to the power of x can be replaced with a y squared now, right? Now, people don't like that way because they're just not comfortable with the switcheroo from here to here, and it just seems like cheating. So I will show you the way that the other people, the other 6 years, actually wanted to do it. What they did was, instead of changing it to 2 squared, they changed it, the 4, into a 2 times 2. Now, the thing is, both of the 2's are still in the bracket of the power of x, because the 4 was to the power of x, so whatever you change the 4 into is also to the power of x. You cannot just say, oh, the power of x only exists on the last 2. If you're changing, the power of x was on the 4, even if you change the 4 into 1 plus 1 plus 1 plus 1, it's still all to the power of x. You cannot just decide, and that's what a lot of you are doing, and I think it's just, again, you just didn't practice this stuff as much during COVID. But then this would follow the 8th rule, I think, in your log tables. You just want to make sure about this. It has a to the power ab to the power of p is equal to a to the power of p multiplied by b to the power of p. And again, all these letters being side by side implies there's multiplying. There's an implied multiplying in between the a and the b here, and in between the a and the b here. But because we're using numbers, it's probably safer to actually do it properly. So this would say 2 to the power of x multiplied by 2 to the power of x. Just literally doing this where a and b happen to both be 2 and the p happens to be an x. If people have an issue with that, let me know. I know that can be fishy. But then that's y times y, which is y squared. So they both end up getting you the same thing. This one looks shorter, I know, people are going to say. But the problem is, imagine if it was like 32. My example, I would have changed it to 2 to the power of 5 to x. And then I would have eventually swapped it around to be 2 to the power of x to the power of 5. Yeah, that should be a bracket there. It's just gross. 2 to the power of x to the power of 5. And then I would have had y to the power of 5. But if you do it the other way, you'd end up with 2 by 2 by 2 by 2 by 2 to the power of x. And they would all turn into 2 to the power of x, 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 and 2 to the power of x, which would all turn into y's, which would be y times y times y times y times y, which would be y to the power of 5. So it's a weird one. That one does work, and in all honesty, you're never going to get something this big in the Leaving Cert. I can't imagine. Maybe, but either way, there's a lot of shit there that is irrelevant. You don't need. This isn't part of the question. I don't want people to get confused. Actually, that's not part of the question. You'll need to pick one of these two boxes, these two rectangles. My way, the wrong way, right? But basically, the whole takeaway from this is, and I've made such a mess of this, I'm going to change the color pen. The 4th power of x in here, we've realized can be changed with a y squared. And the 2 to the power of x plus 1, which is here, can replace with a 2y. So, my new equation from the question now, instead of 4 to the power of x, I'm going to write y squared. So instead of this guy, that's him dealt with. I figured out I can replace him with y squared, so I did. Then minus, but instead of 2 to the power of x plus 1, which is like over here, we figured out we can replace it with a 2y. So I'm going to write 2y, and then I'm going to write equals 3. And that is just writing the equation in terms of y, and that is the answer to that question. Given that x or y can replace 2 to the power of x, express x as an equation in terms of y, that's it done. And then part 2 said, hence find the value of x correct to 2 decimal places. Now, if you look at this, this thing is this thing. We've just kind of covered it up. We saw this was kind of hideously ugly, so we slapped a mask on it, right? And then what we're going to do is we're going to figure out what this is, and I'll show you when we get there, right? But basically, if you look at this, I'm sure most of you will see that this is a y, well, maybe not. Yeah, people struggle with this. A y squared, a y, and a number looks like a quadratic because it is a quadratic technically. If I hike the 3 across and make it a minus, you could just use the minus b formula on this. Now, it does ask for the value of x, but just bear with me, right? Now, if you use the minus b formula, I want to highlight that in the log tables it says the minus b formula is x equals minus b plus minus the square root. It's only x equals in the log tables because it's implied that their quadratic has an x in it if you look in the corner, right, of that page. Because ours has a y in it, our answers will not be x equals, they'll be y equals, that's all. If you do the minus b, I'm going to just shimmy this down real quick. But by all means, the minus b is easier for you guys. I think almost quicker. Yeah, quicker for you guys anyway, yeah. But yeah, there's 2 values of y. Now, the thing is, it asks for 2 values, or now, here's another thing. It says value, singular. That's a hint. Keep that in mind. If it says values, it's more than one value, it's singular. Sometimes they do that bullshit thing of putting in a bracket and an s afterwards. That kind of implies it could be either, but like once they tell us, we know it's going to be singular. And it says of x, though, and we have y, and that's problematic because that's not what they asked for. However, we know that the y, in the very start of the question, it's highlighted that we can use the y to replace 2 to the power of x. So now we're going to unreplace it. We're going to take off the mask and show that ugliness to the world, right? So we're going to have 2 to the power of x equal to 3, and 2 to the power of x is minus 1. Because I just said, oh, off with the mask. It was y equals, but now, you know, love yourself or something kind of mentality. We're going to change that to 2 to the power of x. Now, in order to solve x, we can do it. We can solve the red things. I know that might seem uncomfortable to people, but again, ask me in real life. Don't worry about it. But if you notice here, the letter we're looking for is stuck inside of a power, so we're going to use the top right of page 21, which says that if you have a to the power of x equal to y, that's interchangeable, and it has those double arrows. Interchangeable with log base a y equals x. So what you're going to do is you're going to change this guy into log base 2, 3 equals x, and this is going to be log base 2 minus 1 equals x. And again, if you put this one in your calculator, it'll say error. And the reason is because remember earlier I told you 2 to the power of x and 4 to the power of x and 16 to the power of x and e to the power of x and pi to the power of x will never be 0. And I said, oh, I put in the 0 to the power of x and I shouldn't have done because that's for minuses. That's here, right? So no positive number to a power and no 0 to a power will give you a negative number. That's what I was trying to say earlier in the thing when I made a mistake putting 0 to the power of x in the list. That list occurs here with the 0 to the power of x. You can never, like 2 to the power, no matter how many times you multiply 2 by itself, you'll never get a minus number. So that's why this will tell you error, you haven't done anything wrong. And that's why, remember we said value singular and we ended up with 2. One of them had to crash out at some point, and that's what happened here. This, you would just put it in your log table, correct, or your calculator, correct to 2 decimal places. I'm not going to do that bit, I could not care less. But that's the final answer to 2 decimal places. Enjoy it. First principles, I'm just going to fly through because I think I did that in the calculus video. So that's anything that we're given in first principles, we christen as fx. Then you have to find f of x plus h. This is, again, you just learn the steps off. But what you do is everywhere you see an x, you replace it with x plus h. X plus h squared. You do that out, you get 17 minus 4x minus 4h. Minus 3x squared minus 6xh minus 3h squared. I've obviously skipped a couple of steps there. Do that out properly. BIMDAS means you have to do the x plus h squared first. Do not try do the 3 first. It will just fuck you up. Do the squared first, then multiply the answer by minus 3. I have skipped steps again because I have done one of these in the calculus video, and I know this video might be too long and I know you are going to bitch and moan about it, but that's fx plus h. This thing kind of gets carried down, right? So I could keep writing it all the way down on the left, but if I don't write it here, it's kind of just implied that it just continues on until I state otherwise, right? That's something else that I'm doing that people don't really spot. Maybe it's just something that, I don't know, you don't do nothing with maths to kind of notice that. That's kind of just what's implied. Now, the next step, so that's like step 1, step 2, or step 2 and step 3. It just depends on how people highlight it. But you have to do f of x plus h minus f of x. And you'll notice that just means all of this, take away the original guy. So if I take away a 17, you'll notice this goes away. If I take away a minus 4x, minusing a minus 4x is really like adding a 4x. So that would cancel out this guy. And minusing a minus 3x squared is like adding a 3x squared, which would mean I cancel out this guy. And you'll notice all we're left with is the h terms. And that's how it should kind of work out, right? When you're doing these, you should always just be left with all the h's, basically. I have crossed stuff out and made a mess of it, but you can always rewind the video, I suppose, and just know what's going on. Now, the next step, I'm doing it here to skip a line. I would advise you guys do it out properly, but I'm just being lazy. You divide it by h. And then what you end up with is minus 4 minus 6x minus 3h. Because if you divide these two by h, they cancel out the h's. If you divide the h squared by h, you're still left with a single h. People might be giving out about my h's. I don't care. But then your last step is when you do lim as h goes to 0. You need to write this in of fx plus h minus fx over h. Which is just this guy, but everywhere you see h, you just sub in 0. Now there's more thing in that than you guys are kind of seeing in this, but it doesn't really matter for now. If you want to actually ask, I would have rabbited on about it. But you'll notice you can always check your answer by differentiating it the normal enough way, which basically means 17 differentiated, you would just get rid of it. Minus 4x would turn into minus 4, minus 3x squared to turn into minus 6x. And whoa, what do you know? That's the answer. Cool. Now you cannot do it that way to actually answer the question. You will get 0. You have to do it this way. If it says first principles, that's why the person ringed it. It is importante. We're going to go to this one next because I think it's absolute bollocks and I just want to get it out of the way. So, 2 rival phone companies are launching a smartphone, whatever. This whole paragraph is nonsense. Read it. You obviously should read it in an exam. I just know that for this question it's completely irrelevant because they just say basically the sales for these companies can be represented by 2 different functions or formulas depending on which company you go with. This one only exists as long as x is greater than 5. This one is just a quadratic. That's pretty cool. Now, does GX represent an injective function? Nobody remembers these things. If you recall, injective means that the horizontal line test, I don't know, horizontal line test, HLT, I've never acronymed that. I was just afraid it was going to be something rude or some other slang that I didn't know. Maybe it is. But for injective, horizontal line test can hit it 0 or 1 times. Surjective can hit it 1 or more times. So it could just keep going forever, right? As long as it's 1 or more. And bijective is if you do it once exactly and no other number, right? So those are your kind of categories for a horizontal line test. It says is GX, which is this one here. It's not fantastic that I've traced over it, but I just want to highlight which one it is without having to point at my screen like an ape. They're asking, is that injective? And injective means, again, 0 or 1. But you notice that it's kind of shady that they did it because it's very small. But you could actually draw a horizontal line here that hits it twice, which does not fit into the injective category. So you just do a big fat no, and then you say, like, horizontal line test hits it twice. The official way of saying it, if you want to put it in English, is that there is a Y value that has 2 X values, or there's an output that has 2 inputs, and that's a big no-no for injectivity. And that's that. Based on the marketing team's models, there will be one occasion when the number of phone sales will be equal to for both companies. I'm going to rub out this. Oh fuck! I'm going to rub out this just to make it more obvious. And that's, I think we can all agree that's going to be here on the graph. It's basically when they're saying that their sales match. So there'll be a certain month that when they're in, their sales will be the same amount. Now, what some people tried to do was they tried to sub in numbers for X until they got a number that matched, which is fine. You could sub in 1 here and 1 here, and they go, oh, do they match? No. Sub in 2 and 2. But the problem is, it just says X has to be greater than 5. So you might as well only start at X is equal to 6. People were doing 1, 2, 3, 4. And then if you put in 5, your calculator actually tells you it's an error, because that can't work. It's undefined, and people were freaking out. But what we would do is, if they say, when are they going to be equal, what you do is, kind of hinted at here, if they're equal, that means fx is equal to gx, right? That's just the maths way of saying it. But instead of fx, we can write 13 over 5 minus x. And instead of gx, we can write x squared minus 2x plus 5. And then it just becomes algebra. Now, I'm not going to say it just becomes algebra as in it's easy, because what you would end up doing here is, the only way I can think of doing this is multiplying both sides by 5 minus x. To cancel out the fraction, you're left with 13 is equal to 5x squared. Now, my problem with this is it's just going to turn into a cubic. I can't think of an easier way to do it off the top of my head. It does seem like a lot. It seems like a lot in this one question just to do this one thing. You bring a 13 over, make it a 0, or minus 13. There's a 0 left on this side. You'd have minus x cubed plus 7x squared minus 15x, just if you add all the like terms, and then the 25 and the minus 13 that I would have brought over would have been a plus 12. Now, technically, to solve this, it's a factor theorem question. And if you recall, for factor theorems, I can't remember if I've done another video, but you guys are used to nowadays where they'll say, oh, one of the answers, power of 3 means there should be 3 answers. Power of 2 would mean there's 2 answers, so that's why a quadratic has 2 answers. We have a minus b formula for quadratic. There is a version of a minus b formula for cubic, but the problem is it's so big and so long that we do not actually want to use it at all. It's atrocious. So instead, what we used to do was, what they'll do for you is they'll say, one of them is this, what are the other 2? And what you'll do is you'll use the first one they give you to kind of find out what the other 2 are by using long division, breaking it down to a quadratic, and then using the minus b. You notice here, I don't think they've mentioned any example of where they do match, so you have to guess the first one, and that's more of an old school way of doing it. And you guys wouldn't have known that, but basically what you do is you take the last number, which is 12, and you find its factors, and the factors are 1, 2, 3, 4, 6, and 12. So it can be any of those numbers, or their minus versions, minus 1, minus 2, minus 3, minus 4, minus 6, minus 12. So what you would do is, you just have to take all of these and sub them in here until you get 0. So like if I pick 1, that would be minus 1, plus 7 is 6, minus 15 is minus 9, and then plus 12 is 3. So that doesn't work, so it's not 1, right? That's literally the process we'd have to do, and then we'd have to go through 2. Now, give me a second. That's going to be, so it's not going to be -1. Is this what they wanted to do? Was it? That's kind of madness. I'm going to pause it, and I'm just going to do the bit on the calculator just so the video isn't as long as it needs to be. But basically what I'm going to do is I'm just going to sub in different values into the x and just see until one of them works. Okay, I know it's momentary for you, but I've gone through them and I found out the 4. When you sub in 4, you get 0. So 4 is one of your answers. So x is equal to 4, right? I'm hoping that was, I had paused it. I'm still trying to get a hang of it. I'm hoping I paused it and you didn't hear me like just singing while I was typing into things. But basically, we know x equals 4 as an answer because we can sub it into the cubic and get a 0 as an answer. Now, yeah, hang on a second. So x is equal to 4, right? None of the other ones I think actually came up with an answer of 0. So, but it's telling us that k is a natural number, but k has to be bigger, the x has to be bigger than 5 for that function to make sense. So that means that it's a number bigger than 4 that is a whole number, but that would only imply 6 or 12, but I don't think either of those actually gave, when I did them, I don't think either of those gave a 0. I'm going to do this the official way, and if it's not right, then at least you've learned how to do factor theorem. We'll take that into account. But I don't know if it's me is fucked up or Dave fucked up. Because this is a mock question. It could have been... yeah. This is how you do it. This is how you do it. You get a cubic. The only way you can solve a cubic is factor theorem. So basically, I'll show you how to do factor theorem. If it's not how you do it, I'll say that at the end. Keep that in mind from going forward. Here, the bit I'm doing in blue is factor theorem. I will know when I get the answers what's going on. Well, like, I'll know that I don't know what's going on is one of the things. But this is the root then. X equals 4 is a root. This is factor theorem shit. That if you can sub in 4 and get 0 as an answer, then x equals 4 is a root. But that means that factor-wise, x is equal to x minus 4 is equal to 0. Because for the roots and the factors, you swap them around like that. Again, if you want to know much more in detail, ask me IRL. But then if you remember in factor theorem, what we're going to actually do is we're going to do long division. Now, I know everybody loves long division. So you do this. Then first into first is minus x squared. That would be minus x cubed. That would be plus 4x squared. Draw a line, change the signs. They cancel. Then here we're left with 3x squared. You bring down the minus 15x. You do the whole process again. That's going to be plus 3x. Then that's going to be 3x squared. That's going to be minus 12x. Draw a line, change the signs. They cancel. This is minus 3 plus, you bring down the plus 12. That was minus 3x. Sorry, I forgot to write that. That would be minus 3 up here. Whip the minus 3 across. You get minus 3x plus 12. Yeah, and that was, I was lucky there. Minus. Cancel. 0. Hurrah. Now, the quadratic is the answer. This guy up here. So it's going to be minus x squared plus 3x minus 3. Yeah. And that is, sorry, that doesn't work. You'd have to do the minus b formula for that, and you'd end up getting minus 3 plus minus the square root of 9, well, 3 squared, sorry, I'll write out the official way. 3 squared minus 4 times minus 1 times minus 3 all over 2 times minus 1. And inside there, you get complex roots, right? You get like, it doesn't really matter. That's going to be something gross, like a 7, square root of 7, I, minus, it's going to be like 3 over 2, plus or minus the square root of 7 over 4, I, right? That's horrific and not what they wanted at all. And maybe I fucked it up because that's actually so bad. The answer is just x equals 4 is what k is, because there are 3 answers, and hypothetically I've got my 3 answers to be 4 and 2 complex roots. But they said k has to be a natural number, so I'm guessing it has to be 4. The problem with this was that it said x has to be greater than 5, which is just a complete shambles. Unless, now I'm saying all this, someone's going to point out I'm actually the shambles here, I say. But I can't see. I equated fx to gx, which is what you're supposed to do when they're equal to each other. I got rid of the fraction by multiplying both sides by 5 minus x. Multiplied it out, got a cubic, did the cubic. Maybe I goofed up multiplying it out. I wasn't really paying much attention when I did that. 5x squared minus 10x plus 25 minus x cubed plus 2x squared minus 5x. Yep, the minus x cubed, yup, the 5 and the 2 made the 7, the minus 10 and the minus 5 made the minus 15, the 12 and the minus 13 made the plus 12. 4 works. We got 0 down here, which makes me think that's right. Yeah, I think that was actually a shit question. I'd be curious if someone has to. I'm going to ask someone actually if one of the teachers put up the corrections for that and just see. I could have some blind spot where I'm just not paying attention. I'm just not seeing it right. And I'll see it and I go, oh, balls, but I couldn't be arsed editing the video or whatever. So that's just what you have. That's my opinion at this moment, where I'm tired enough that I'm messing up numbers, which shouldn't be the case, but however. So that's my opinion, that they kind of scuffed that question a bit, because they said k has to be a whole number, because k has to be a natural number, but the only natural solution to that, as far as I could see, was 4, but they also said that x has to be greater than 5 for the function to work. I don't know if that means silliness occurred, because this is a mock question, so there might have been some sort of weird thing like that where they didn't take that into account. Or it could be that I fucked it up. That's completely possible. But I guess we'll take that as a learning thing, and that if you were to do it yourself, that's the same logic you have to go with. You have to go with, well, fuck it, I got an answer, right? So, yeah, in the marking scheme, you will get marks for doing the right method. If you, even if you don't get the right answers, if you've proven that you've done it the right way and you just scuffed it or messed it up somewhere along the way, you still get the majority of the marks. And I'm kind of treating that the same way, where I've done the right method, and the answer's nonsensical in my mind. But again, this is a mock question, and there's so many more questions. I don't want the video to be too long. I'm just going to push this out, and if one of these, I'm going to ask one of these for the corrections, I suppose, if one of the teachers has done it up, and just see what someone else who's good at the maths, maybe they have it better, and I've just missed something. But if we skip to the next bit, it's f minus 1. That is the inverse of f, and the inverse basically means what would undo f. If you remember, if to find the inverse, what you would take is you take the fx, but instead of fx, you can write it as y. And it was equal to 13 over 5 minus x, because that is what the f was in your question originally. To find the inverse, you need to rearrange it so that the x is eventually on its own. I'm actually just going to scratch the fx equals, if that's okay. Basically, I just replace the fx with a y. But in the same fashion here, like I did earlier, but as we saw, it did go into weirdness. Multiply both sides by 5 minus x. That's a 5. And then these cancel. And then you end up with 5 minus x. Jesus, what is wrong with me? 5 minus x, 5. Minus x times y is equal to 13. We want to get x on its own, so what I'm going to do is I'm going to divide both sides by y. And get 5 minus x left on the left-hand side, because they cancel. Equals 13 over y. And then bring the 5 across, and it would be minus x is equal to 13 over y minus 5. And then multiply the whole thing by minus 1, and you get x is equal to minus 13 over y plus 5. And then, so at the very last step, and I'm going to do it in a different color pen, because this isn't actually a maths thing that we're doing. We're just kind of saying, oh, well, therefore the inverse must look like this. And what it looks like we're doing is we're just swapping them around. But like, we're not actually doing any maths there. People say, Graham, that's bollocks. You can't just swap the letters around to make it what you want it to be. We're not saying that that's what you do. You're just kind of saying, oh, that's what the inverse would look like, but the inverse has to be y equals with an x in it, so we're just going to swap it back around. And that is the inverse. You can always check it by picking a number to sub into the fx, and then getting an answer, and getting your answer, subbing it into the inverse, and seeing that you go back to the OG thing. I'm not going to be too pushed about that. If you want to ask about inverse, by all means. If you want to look it up yourself, even, you don't even have to ask me. I'm sure your teachers are more than willing to dive into that one. Oh, yeah, I should have skipped this one before that previous one because this question is extremely similar to the one I did up here, where you'll notice that it was a weird, now I've covered it all up, it was a weird starting off thing. It looks horrendous. Nobody wants to do that. But now here they didn't give the hints. This is what they'll do in the actual leave insert, and hopefully we'll just do enough things before your leave insert that you might spot this. You kind of have to spot that what you want to do is you want to do your own substitution. We're going to say, and I'm going to assume it's y is equal to 3 to the power of x, because you notice here it's kind of lined up like that. So I could have it as minus 28y plus 9, and then we're still going to have to change the starting off bit, but that implies to me that's going to be a quadratic in y's in some way. So we're going to have a look at it. So what I'm going to do is I'm going to use 3 to the power of 2x plus 1. I'm going to use the first rule from page 21 in my log tables again, where it says if I have this, I can write it as a to the power of p plus q, but again, I'm going to use it in reverse. So then this breaks down into 3 to the power of 2x multiplied by 3 to the power of 1. Not forgetting that, of course, brackets are probably more useful here because they're numbers. That's 3 to the power of 2x multiplied by 3. Then that's going to be 3 multiplied by 3 to the power of 2x. Now here's where people don't like it. We kind of have to do what I was saying earlier, that I was kind of saying you could avoid it in the other question. If you think about it, you can write that like that. Now I'm not saying you should, I'm not saying you have to, but if you do that and then follow this rule, but in reverse, what you can do is you can break that up into 3 to the power 3 multiplied by 3 to the power of x to the power of 2, which can then be subbed in, because we said y can be subbed in for 3 to the power of x, so it's 3y squared. Now the reason, technically you don't need this line, because some people will spot to go from here to here straight away. What I'm trying to avoid is some people will try use this rule here on this line and end up getting 3 multiplied by 3 to the power of 2 to the power of x, and you notice you cannot replace anything there with the y. There's no 3 to the power of x there, so we don't want to do it that way. It's just something you have to do enough that you kind of cop, oh, I want to have the squared on the outside. I want to have the x on the inside, sorry, rather, because then we know that 3 to the power of x can be replaced with the y. So we go back up here, this can just be 3y squared, and you notice that is a quadratic. Hurrah again. Use the minus b, or I will just use this so I can actually get the answers out quick. I say that, and yes, I did. I think I got that right. And you do that, and then you'd get y is equal to a third, and y is equal to 9. So that's why some of your teachers are telling you to do this way instead of the minus b way. You saw that's quicker for me, and it's quicker for your teachers, and I understand the logic that they want you to know how to do it, and I get that. I've just seen way too many mathematical casualties where people have just fucked that up like beyond belief, and you all forget how to do it from junior cert, and maybe what we should do is we should spend a lot more time doing that, but you guys constantly get new stuff and more stuff to do, and integration and calculus, and you're getting trigonometry, and you're getting the circle, and you're getting the line, that we don't really have time. The minus b formula is so handy for you guys to do on the calculator. That's why I advise you to do it on the calculator. Technically you're supposed to know this, but doing it in a way, the question that comes up that won't allow you to do the minus b formula is like 1 in every 20. Maybe, yeah, in leave insert, maybe, yeah. So even if you just completely forgot this way, you can still do the majority of them. I'm not saying, I'm not advising you to do it, but if you can use the minus b, you might as well. But again, for me and the teachers, that would be handy because we do maths all day, every day. You guys don't, so you mightn't be able to do that like that. But back to the question, we found out that y is equal to a third and y is equal to 9. But don't forget, we only used the y as a mask because this was atrocious. Because they said solve that, and they had x in the question, that means they wanted it to be x equals as an answer. So what I'm going to do now is unmask the hideousness. And instead of y equals to the power of a third, it was really 3 to the power of x is equal to a third the whole time. If we Scooby-Doo the scenario, this situation, where we rip off the mask. Look, I'm explaining that because I realize you're all too young. Scooby-Doo is multi-generational. It doesn't matter as I think about it. But we're going to use, again, the top right of page 21 because the letter we're looking for is stuck inside of the power. So we're going to have this again. We're going to have the double arrow. We're going to have a to the power of x equal to y. So the letter we're looking for is stuck inside of a power, so we're going to use that rule. So then we're going to end up with log base 3 of a third is equal to x. You put that in the calculator, you get minus 1 is equal to x. And then you have log base 3 of 9 is equal to x. So that's going to put that in your calculator, you get 2. And your two answers are x equals minus 1 and x equals 2. Happy days, happy days. That's a common enough question, and it's kind of a dick move because they just expect you to spot it. I thought was also a dick move was they put this in with the complex numbers question, and they never really in the leaving cert mix complex numbers with anything that's not complex numbers. So I thought that was weird. Given that z is equal to 2 plus 2 root 3i, I have a whole video on this, I know I do, so I'm just going to kind of go through this. Putting it in rectangular form means you go across a certain number and then go up a certain number, and then where it matches where you put the point. Polar form is where you go in a straight line out to that point. Now, when you're changing it from rectangular form into polar form, you do a shit diagram. It does not have to be good. 2 root 3, you guys are all like, oh, what number is that? I don't care. I don't care. It's a positive. That's all I care about. It's a positive imaginary number. So therefore, regardless of what number it is, I know it's going on this part somewhere from here. It's the top part of the imaginary axis, because the vertical one's the imaginary and the top half is the positive sense, so that it's going to be like here somewhere. The real number is a plus 2, so that's going to be on the real part of the real axis, which is like here. So the point is going to be like in, now it does not matter as long as I know it's in this quadrant. That is the whole point. You guys will spend ages trying to draw a triangle or trying to draw this diagram with the 2 root 3, and you'll be like, what the hell is 2 root 3? It does not matter. It does not matter. It's like 3.5 or something. It does not matter. Once you get the right quadrant, because the whole point is we need to remember the rules. Remember the rules of theta is equal to alpha. 180 minus alpha is equal to theta is what this one is. Theta is equal to that, whatever. Here it's theta is equal to 180 plus alpha, and here it's 360 is equal, or theta is equal to 360 minus alpha, right? So that's the whole point of this diagram, to figure out which of those 4 rules we're going to have to comply with. This one, obviously, because it was in the top right quadrant, it's the easiest one. We're just going to have to do it out like this. I'm going to draw in the wonderful right angle triangle. Don't judge me. Right angle triangle. You'll notice how I'm just slashing these down. Do not spend like too much time. Well, enough time that you're right. I don't know. Yeah, maybe I shouldn't have said that. Now, I didn't write them in here actually, but I should have written in these. Because now from here to here is 2. And then from here to here is the same as here to here. So it's 2 root 3. Again, now, if you recall, polar form is written as or cos theta plus I sine theta, where or is the length of the line coming from 0, 0 out to meet it, and theta is the angle from this line here. It's always from the right side counterclockwise, so we need that angle here. That's a shit diagram to kind of illustrate that. We need this angle here. If the line had been over here, we would need this angle here. It always has to come around from here counterclockwise, always. Luckily for us, it's the easiest one, so that's fine. So we just need this angle here, because in the triangle you always want to find the innermost angle. Like, there's no point finding this one. He's just off on his own. He's doing his own thing. We only care about the inside of the diagram. So that translates to finding this angle here. So we need the length of this line, which would be or, because that's the length of this line, which is what or is. Or is the length of the line that comes out to meet the point. And we need this angle here, because that's what the alpha is going to be that we're going to use later on. 2 sides of a right angle triangle. To find the third, you would use Pythagoras. A squared plus b squared is equal to c squared. 2 squared plus... now, 2 root 3 has to be written in a bracket and squared if you're putting it on a calculator, because the calculator, if you don't put that in, will only square the root 3. If you don't put in those brackets, it'll only think you want to square the root 3, and it will leave the 2 as a 2. That's going to be 4. That's going to be 12. That's going to be 16, and then again the opposite of squared is square root, so that's going to be c is equal to 4, and you get 4 here, so we know or is going to be 4. I shouldn't really have done that just now because I might confuse the issue. To get the angle, you would do SOHCAHTOA, but it's always advised to use tan, and you would write tan of alpha is equal to the opposite over adjacent if you use SOHCAHTOA correctly, and then O would be 2 root 3 because it's opposite the angle that's mentioned, and then the adjacent is 2. To get alpha on its own, you would do tan inverse of 2 root 3 over 2. And if I remember from one of you guys doing this earlier, it's just 60. Yeah, I think that's true. Now, oh, that's not theta, that's alpha, if we'll follow the rule. But in this quadrant, theta is just alpha, so that's handy. So for us, we can just say cos 60 plus I sine 60. There is a way technically of doing this on your calculator, but it's a bit fishy, so I don't always tell you. I kind of tell you as like a way of checking it. One of you little turds just used it and cheated that way. Not cheated, it's still fine. It's just, it made me uncomfortable. morally, ethically grey area. Now, the thing was, this test, it was kind of hinted to you that it was going to be a De Moivre's theorem with a power of a fraction, but it's De Moivre's theorem with a power of a whole number. De Moivre's theorem says that if you do have a polar form, or a complex number in polar form, sorry, to the power of a number, there's an easier way of doing it than to actually multiply it out each time. So if you have this guy where the n is the power put onto the polar form, you would change or to the power of n, and you multiply both of the angles by n, represented by n theta here, if that's all right. And that's what you would do. Now, if it was the power of a fraction, you'd have to change the thetas into theta plus 360p, or whatever I said to you, or n. Doesn't really matter as long as you pick a letter. I just don't like using n because n has already been used for the power and it can be confusing. But because it was the power of a whole number, you just did not have to do that. They just pulled shenanigans on you. So what I'm going to do is I'm going to take this guy. And they said, what is z to the power of 4? We rewrote z, which was this guy, as this. So therefore, it's really, if this is to the power of 4, then this is to the power of 4. Yeah, I'll do. I won't do it there. It's going to be too confusing. Then this is to the power of 4, so it would look like this. 60. Hang on. To the power of 4, like so. And then if we use De Moivre's theorem, it says put 4 to the power of 4 and multiply both of the 60s by 4, which is 240. That's just following De Moivre's theorem. I've done enough videos on that. I think you can find another one somewhere if you are still confused about this. 16 times cos 240 plus I sine 240. Now, I can't remember. What is the answer? Okay. Now, I will say here, most people will just try to write all of this into the calculator. You cannot do that at this point because the I. So what you have to do is you have to do 16 cos 240 first, get an answer, which is minus 8 apparently. 16 cos 240, I'm in degrees, yeah, okay. Minus 8. And then what you would do is you go back in and do 16 cos, or sine, sorry, 240, which is minus 8 root 3. But this minus 8 root 3 will have a dirty I stuck on them because there was an I next to the sign at the beginning. And that is the answer to that question. So a lot shorter when the power is a whole number. They kind of pulled a switcheroo on you. Thought that was, they were probably doing it to make you study more, which I can get. I understand that. But that is it. That is De Moivre's theorem of power of a whole number. Sorry again. A couple of you have given out that I'm too slow doing these, right? So I'm trying. If you want to speed it up, you guys know how to use YouTube and make me faster or slower. It's up to you guys. Now, given that this is the quadratic, rewrite it like so. Your teachers tell you to do some cockamamie way of doing that. Where did that word come from? Doesn't matter. I don't do it that way. What I'm going to actually do is I'm going to multiply this out instead. Don't forget, you do not multiply the a in first. You have to do the squaring first because of BIMDAS. So if you square first, you would get this. That's a b. Don't judge me. B squared plus c ax squared plus 2. Now, the lettering here, it doesn't matter what order you do it in. Normally, people will do it alphabetically, but it does not matter. Just notice that the c doesn't have an a on it because it was not being multiplied by an a. It was only the things inside of the bracket that were being multiplied by an a. But now what we can do is compare and contrast. The x squareds have to match, so that means a is equal to 4. The x's have to match, so that means 8 has to equal to 2ab. Now you'll notice I'm not writing the x's. That's perfectly fine. Some people will write ax squared is equal to 4x squared and then get rid of the x squareds and get to where I'm at. Does not matter. It does not matter a bit. For this one, if the 8 is equal to 2ab, we know the a is 4. I'm going to do b in a bracket there just because I didn't mean to, but sure, look. Then we have 8 is equal to 8b, divide both sides by 8, and you get 1 is equal to b. And then the last guy is tricky for people because the 3 has to match up with both of these because neither of those elements, the ab squared and the c, neither of them have an x on it. So what we have to say is the 3 has to equal both, right? Don't forget it's both of them. But at this point, we know what the a and the b are, so we can sub them in. So we'd say a is 4, we'd say b is 1. Now put that in your calculator. You guys always mess that up. You bring the 4 over, make it a minus. Minus 1 is equal to c. And there you have your 3 answers, a, b, and c. If you want to rewrite out the original, you would write it as 4 instead of a. X is fine, b plus is fine, b is 1, squared is fine, and c is minus 1. So it would actually look like this. And that just means that on a graph, I know that the graph, you take the wrong sign for, now it doesn't ask this in the question. This is not part of the question. The graph is not part of the question. I'm just highlighting that it has been in the past. Take the wrong sign of the thing inside. So instead of the +1 in the middle, you take a -1. The center of the graph is going to be around there. And then the lowest down is actually also -1. So the lowest down it's ever going to go to is there. So it's going to be a U that is kind of mirrored either side of the -1 on the x-axis. But the lowest down it goes is -1 on the y-axis. Like so. Not important, not a huge deal. That's just what the whole purpose of writing it like that is. And very often, a very common part B to that question is, oh, what's the minimum point? And you'd say it's -1, -1, because it's opposite sign of this is the x value. The sign here is the right y value. Now here it says this is a completely different thing. It has a new equation, and it says this equation, where k is a constant, has two distinct real roots. This is something that a lot of people kind of forget about, but there is kind of a rule here that what would I write? So I go through again. If people want to actually understand why this is, ask me. But this can go three different ways. Either it's greater than 0, it's equal to 0, or it's less than 0. And you just kind of have to learn these off. These aren't things in the log tables. It's greater than 0 if it has two distinct real roots. Distinct is just a fancy word for different, but I'm going to use distinct because it's the word that they would use, but it's not the word that we would use in real life, so I want you to kind of get a bit more comfortable with it. Two real distinct roots. If it's equal to 0, it's two equal real roots. And we all know the word equal, it just means the same, right? So you get the same answer twice is what that means. And then the last guy is, if you'll excuse me, it just takes a minute to write this. This means that you have two non-real roots. Now, I could write not real or non-real, but if you remember, non-real means complex. Two complex roots. Now, another way of saying that would be no real roots, if you agree with me. Like you could say, or 0 real roots, if you follow me. Now, those are your three different scenarios. Two distinct real roots, two equal real roots, or no real roots at all, which would be two complex numbers, two complex roots, two roots that have an I term in them. Here, because it said two distinct real roots, it basically implied that b squared minus 4ac has to be greater than 0, because that's two distinct real roots. So basically what you would do is, now again, this person has written it in as maybe a correction or something, I guess. B squared minus 4ac has to be greater than 0. Now, where do you get a, b, and c from? Don't forget, a is the thing in front of the x squared, b is the thing in front of the x, and c is the thing on its own. This bit, the bit that says show, everybody kind of tried to use that, but when it says show, you can use it, but it's unfortunate for you guys that you guys just haven't done enough of these to kind of understand. It's not that you just not understand something, but it's just that when you do it enough, you kind of know when they wanted to use that and when they wanted to get to that. Like, use other maths to arrive to that. And here they wanted you to arrive at that conclusion, not use that as the starting off point. But if I say b squared minus 4ac is greater than 0, and a is the number in front of x squared, I'm going to use your boy up here. A is a sneaky 1 that's in front of the x squared. B is a k. I'll write them over here, I suppose. A is equal to 1, b is equal to k, and c is equal to k plus 3. I know there's going to be an argument about my k's. I know. It's every time I write them, some little whiny shit who, keeps writing his 3 backwards as I go. But that's what we do. We use the a, b, and c kind of like we were doing the minus b, but we're not doing the entirety of the minus b. You'll notice we're only doing the b squared minus 4ac, and we're just kind of saying it's greater than 0. So then it would be k squared minus 4 times 1 times k plus 3. When you're multiplying three things together like this, like the 4, the 1, and the k plus 3, do the second two brackets first. Do the 1 and the k plus 3 first. You guys mess it up all the time. All the time. Now, luckily for us, multiplying by 1 is easy to do. But always do these two first so that we can leave the minus till the very end, right? Because that bit throws people all the time. We'd have k squared minus 4k minus 12 is greater than 0. And oh, would you look at that? That's what we have to try show. Now, I put the line through it rather than under it, so I'll get rid of it. But that is the answer because it says show that is true. And if it has two real distinct roots, that is true. Now, hence, find a set of possible values for k. This is weird because you kind of had to just completely ignore the rest of this shit. Just ignore everything else. And just kind of pretend this is a quadratic inequality. And that's it, right? So, That's what we're going to do. We're going to solve the quadratic. Now, again, in Leaving Cert, again, I never said this, but in Leaving Cert, the inequalities generally will end up being a quadratic. They might be framed differently at the start, where either it's going to be a modulus or it's going to be a fractional one, or a rational one is another way to say that. I won't get into that too much here. You can find that somewhere else or ask me about that. But whenever you get a quadratic, they're saying when is that quadratic greater than 0? That means on a graph, if it's a positive k-squared, it's going to be a u shape. So on a graph, they're saying when is that quadratic going to be above 0, which is code for when is that graph going to be above the x-axis. They do not explain that properly to you guys. I don't really get it, because I understand what they're saying and they understand what they're saying, but there's some disconnect between the teachers and me and you guys on this one. I'm not sure. But basically, all of these points along here, you get that if I was to put these in, these would all have y values that are positive, whereas these horrible green ones down here would have y values that are negative. Negative y values down here, positive up here and up here. And in the question they said, when is it going to be greater than 0? What numbers are greater than 0? The positives. So they're basically asking for the red points. Now, you can't do that on the diagram. You can't say, oh, this red bit is fine. That's what they were trying to do when they highlighted the shit, but nobody ever got the highlight, and I don't know. So instead, yeah, I've done that out. So we know that we're actually looking for the two arms here. The two arms here and here suit the scenario of it being above 0. The in the between bit does not, so we're not going to include that. So the thing is, we need to find out what's here and we need to find out what's here. We need to find out the cutoff points where it stops being what we want. And to do that, we need to find out where does this graph cut the x-axis, and how do you find out where something cuts the x-axis? You do, well, if it's a quadratic anyway, you use the minus b formula, or you do the brackets again. If you do the minus b, what you do is, right, you do it as if it's an equals. People don't like that. They're like, how do you change it to an equals? We're not changing it. We're doing a completely different question first. We're doing the minus b or the brackets to get here. Oh, fuck. You would do minus 6k plus 2, I think. K is equal to 6. You would do k is equal to minus 2. Now, the smaller number is always going to be on the left because the number line is always the bigger number to the right. So we know that the two roots, this is just like a completely different thing just to find the roots of it, right? This is not a continuation. This turns into this. It is just a completely different thing. So I put it equal to 0 so that we would find the roots. And now that we found the roots, we know where it crosses the x-axis. And we know that, as we said, the red bits were always like here or here. Oh, I missed it, but you get what I'm saying. Or here. So you can't answer, but you get that. What I'm saying is, we need to say to the left of minus 2 and to the right of 6 on the x-axis. And the way you would write that is, you would say the numbers to the left of minus 2 are smaller than minus 2. So you would say x is smaller than minus 2. And the numbers to the right of 6 on the x-axis are bigger than 6. So you would say x has to be bigger than 6. They have to be two separate things. You cannot put them together. I swear to God. You guys are like, no, Graham, don't worry. I figured out a way. You cannot do it. I promise you. Do not come back at me and be like, I think you missed this, because I fucking didn't. Swear to God. There you go. Now I did X. I should have written K. That's on me, in fairness. I was ranting at you guys and then I fucked up. But find the set of possible values of K, and you're going to say as long as K is smaller than 2 or K is greater than 6, you will get the quadratic greater than 0, and that's what it asked for. Happy days. Oh, are we almost done? We have the flu. Yes, that's all that's left. Thank God. Now, I don't like the wording on this question. I will be honest with you from the start. This bit that's underlined here, I think is slightly off, ever so slightly. So it's when you read all this, it basically tells you a group of medical students at a certain university are studying the number of students on one campus or on campus who began showing flu-like symptoms during the month of January. The population of students displaying symptoms can be modeled using the function blah, where a and b are real numbers. That's fine. T is the time in weeks since the beginning of the study. Now, it doesn't highlight it particularly well, but P is the amount of students with the symptoms. And the way you can tell that is they could say the population of students displaying the symptoms using the function P. That's kind of like the way you'd read that. You'd say, oh, the population of students studying or displaying symptoms. And then they say blah, 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 function. And then you just say P. So population of students displaying symptoms is P. This t in brackets, don't forget, in a function name, if there's a little letter in brackets, we don't actually functioning, it's not a functioning thing. We don't actually use it. So, like for example, a way you can consider that function is you can consider it p and equals a e to the bt. You can consider it like that, where there's just no t there at all. What you can do is actually consider it to be a ghostly t, where it's kind of like just chilling there, but in more as a, it's an indicator. That's what it is. It's an indicator that there's technically going to be t's in the p function. You do not do any maths with that. Some people were subbing in for the t there and then multiplying it by whatever they subbed in for the p. Do not do that. I'm stressing that. Now, the bit that I don't like is they say t was in weeks, time in weeks, and they say on the first day. Some people could argue that that means t is equal to 1/7 because it's 1/7 of the way into the first week. But it's a way that they were trying to do it, that they do it very often in the Leaving Cert, where what they end up saying is they ask you to sub in that 0 for t. It's a very common, well, like it's not every year, but it's a common enough question that they'll ask you to do, but they'll never actually just say, oh, here, sub in t is equal to 0. It's always like at the start of the study, how many students were there, or before they began, how many students were there, or how, it might be a formula that tells you the height of a ball, and they might say, how high was the ball when it was hit, and t is the amount of time, the amount of seconds after it was hit. So when it was hit, 0 seconds have passed since it was hit, and then you sub in. It's a very, basically, if they give you a weird thing that you can't sub in a real number for, but they don't give you a real number, just sub in 0. That's probably what they're going for. But only use that as a last resort. Don't just like willy-nilly go like, oh, Graham said, so I'm just going to throw that in. On the first day of the study, 4 students were displaying flu symptoms, and as this person has written in, that means that when t is equal to 0, p is equal to 4, because t is the amount of weeks that have passed, and 0 weeks have passed, and p is 4, so that means 4 students were displaying symptoms, because if you remember, p is the population of students that were displaying symptoms. They also said after 7 weeks, 23 students were showing flu symptoms, and they said using this information above, show that a is equal to 4 and b is equal to 0.25, correct to 2 decimal places. Now, people would say, oh, they put the answers into the thing, I'm going to use them in the question. I don't want you to. You can technically answer this question using them, but I don't want you to, because I want you to be able to do the questions if they didn't give that to you. Like, for example, sometimes the questions can be, they just would not tell you that, and they'd say, what are A and B? And you would go, oh, balls, I don't know how to do this. I'm used to subbing the numbers in, but we don't have the numbers, so what do we do? So the way we would do it is, and this is why they gave you 2 scenarios. They gave you 0 weeks in, 4 students, and they gave you 7 weeks in, 23 students, because there are 2 bits of information to find, and a very common one for these questions is to do this. So instead of p, t, I'm going to put in 4. Note that I'm not actually putting in anything for the t, because that is a ghostly t. We do not use it as actual maths. 4 goes in place of the t. A is A. E is just that E that nobody likes. B is B. And instead of t, we can put in 0. But if you think about it, that's A, E to the power of 0, because B multiplied by 0 is 0. But anything to the power of 0 is 1. So that's A multiplied by 1, which is just A. So we can, now I'll just abbreviate that really. I cut out the middleman. You end up with 4 is just equal to A, That's that. And that is what they asked you to do. Show that A is equal to 4, done. And now it says we also have to do B. So this is why they gave us 2, because now what we can say is instead of P, we can put in 23, because 23 students were showing flu symptoms. Now instead of A, because A was a constant, and as I said earlier, if you know a constant, it means you can just use it for the rest of the question, and now we know A is 4, so we can use it here. We can say B is still B, T is 7 this time. That means 4e to the power of 7b. Now, the thing is, we have 23 is equal to 4e to the power of 7b. The letter we're looking for is stuck inside of a power, so we're going to have to resort to the top right of page 21 again. However, that rule, and I should really stress that more, that rule only works when there's nothing else other than the base and the power. The power and the thing the power is resting on. And you'll notice in our example, we don't have that yet, because we have a 4 stuck in front of it, which is neither the power nor the thing that the power is on. So to get rid of it, we're going to divide both sides by 4. They cancel, and you get 23 over 4 is equal to e to the power of 7b, which is gross, but it is correct. If you follow the top right of page 21, it would end up being log base e is of 23 over 4 is 7b. Now, what someone the other day felt a bit betrayed by the maths world, right? But log base e is the same as ln, so you can actually just write it like that if you want to instead. This is and this, they're both the same thing. They are both fine. It does not matter. felt betrayed because he thought log base E, or what was it? He thought ln was a good guy, and now he's realized he's not, or something. I don't know. You felt betrayed and very emotional about it. But if you do ln of 23 over 4, oh yeah, then what you would do is, sorry, let's say we do ln of 23 over 4 is equal to 7b now, right? Just if we leave out this guy. You don't want the 7 on the b, so you divide both sides by 7. Cancel that out. And if you put this into your formula, I guarantee, or into your calculator, I guarantee you it will be 0.25. Now, I said that without typing it in the calculator first, which, you know, maybe I should have now that I think about it, because I'm after guaranteeing it and it didn't work. But yeah, it was fine, because it was 0.249. 0.249, but to correct that to 2 decimal places is 0.25 is what b is, and that's what they asked you to prove. Happy days. And that's what they'll do. They'll very often put 2 letters in, one in the power and one not in the power, and then the one in the power will disappear when you sub in the 0, and you'll be able to find the first letter fairly easy, and then sub in the first letter into the second one, or sub the first letter into the equation to find the second letter, along with the second case scenario, which doesn't have a 0 in, so the b doesn't disappear, and you're able to calculate for b. Find the number of students who displayed flu symptoms after 15 weeks, correct the nearest whole number. So that is literally just 15 weeks, and they told us t is the time in weeks, so that just means 15 is t, yeah? Yup. That's what t is. And then all you would do is you'd say, well, now what is p equal to? Now, what some people would do is here, instead of just writing p equals, some people write p of 15. Now, that does not mean p multiplied by 15. That means what happens to the p function when we would change the t to a 15. They are both legitimate. They are fine. A is 4, E is E, B is 0.25, T is 15, and it says correct the nearest whole number. If you just slap that into your calculator now, that's kind of annoying to people. I feel like that it was so simple compared to the start, and I think people would have been able to do it a bit more if they weren't so like kind of crestfallen after the first one. I rounded the nearest whole number. I think I'm getting 170 for that. But people were so kind of, I get upset and annoyed by the first bit here that they didn't really kind of necessarily get. Well, some people actually just did this without doing that, which is fine as well, because they did tell you what A and B was. Now, how many weeks did it take for 50 students to display flu symptoms correct the nearest whole number? That's basically them saying what would we have to sub in for T to get 50 students as the outcome. Yeah, so they're basically saying what number could you sub in for T, and you could just keep subbing in numbers for T, but the problem is it's very hard to get it, and also actually for certain questions they'll leave insert if you did that. There was 1 or 2 in the marking scheme where they said don't give them as much marks if they did it that way, so just try avoid just subbing in numbers for T. Basically what it means is instead of the P we can put 50 though, because 50 is the amount of students who are suffering with flu symptoms. So in the formula, instead of subbing in for T, sub in for P. And we'd have 0.25. Now, the problem is we wouldn't know what T is, so it's still going to be 0.25 T. But hey, look at it again. The letter we're looking for is stuck inside of a power. We're going to have to resort to the log bit over here that I've left part of it off of the screen. But again, that only works if we have the power and the thing that it's resting on. So we need to get rid of the 4. So we divide both sides by 4 first. That cancels. And we're left with 50 over 4 is equal to e to the power of 0.25 T. Again, though, if we follow the top right of page 21, I'm just going to move it just so you can see what I'm talking about. This guy again. What we're going to end up with is we're going to end up with log base E of 50 over 4 is equal to 0.25 T. Log base E can be written as ln if you want to. That's a button on your calculator. You could always just type in the full boxes as well, the one on the very top right of your calculator. To get T on its own, we divide both sides by 0.25. And then just slap that all into your calculator. And the final answer, and I think we're done after this, and hopefully I could just stop, and hopefully the video wasn't too long. I haven't been keeping track. I've just been enjoying myself. You know how it is. 0.25. It's saying that T would have to equal to 10, corrected nearest whole number. So it means that it would have to be 10 weeks in before 50 students had flu-like symptoms. Okay, hopefully that's it. Hopefully I didn't fuck it up anywhere. I know I made that issue with the simultaneous. I messed that up slightly. I hope that hasn't messed you guys up. Hopefully you'll be able to see it. Hopefully you'll be able to figure out what's going on. If there is questions, by all means, as I said, ask me in person. Do not just kind of go, oh well, I'll never figure that out. If you want to know more in depth about certain things, or if there's a topic you're like, I still just do not get this, we can go through this. Just ask me. Okay. I hope you had as much fun as I did.